Hi guys, welcome to my channel where I'm going to be helping you out here to work out some past papers for Namibia Senior Secondary Certificate. I'll be doing that for ordinary level and for AS. Okay, so we start with this paper here for 2022 paper 2 AS, and straight away I'll go to question number 1, which is 1A. Now, in this case here, we are asked to solve the equation modulus of 3x minus 1 is equal to 4. Now, that's a modulus equation here. Now, a modulus equation, what we do is that for us to solve this, we solve that using the definition. If I can just briefly look at what we mean by the definition of that. So let's say we are having a modulus of ax plus b is equal to c. The general thing that we are actually saying here is that we need modulus means that we can consider this to be positive or negative. So if we consider this to be positive, it means this positive expression is going to be equal to c. So we are going to have ax plus b is equal to c. Now that's for the positive. What about if we consider that to be negative? What is it going to be? It's going to be the negative of this is equal to c. So I'm going to say here in brackets negative ax plus b is equal to c. All right. So if we divide both sides by negative, what are we going to get here? We're going to have ax plus b is equal to negative c. All right. So we have these two equations which we then need to solve, okay, separately. So this for the positive and that for the negative. So that is actually the general definition, okay, that we are having here. So looking at our equation, what are we having? Okay, let me erase this, what I just said here. I'm having here 3x minus 1, modulus of 3x minus 1 is equal to 4. So applying the definition, what does that become? It becomes 3x minus 1 is equal to 4, or 3x minus 1 is equal to negative 4. So that there is for the positive, and here it's for the negative. Okay, so we are going to solve these two equations separately. So the first one is going to be 3x minus 1 is equal to 4. So we're going to get negative 1 to that side. We're going to get 5. All right. Or if we solve that one there, what are we having here? We are having 3x minus 1 is equal to negative 4. So if we take the negative 1 to that side, again, we're going to have negative 3. Okay. Remember, you can actually choose to solve this on its own first, and then you go to the next one. Okay, so let me finish up with this one. So what am I having here? 3x is equal to 5. If I divide both sides by 3, I'm going to get x is equal to 5 over 3. Or on the other side there, 3x is equal to negative 3. What am I going to have? If I divide both sides by 3, I'm going to get x is equal to negative 1. All right. So these are my solutions. But of course, remember, when you solve a modulus equation, you need to make sure that you check the solutions. So what it means that if you substitute this there, you must get your answer is 4, and you substitute this one also in there, you must also get negative 1. So if we substitute 5 over 3 there, what are we going to have? On the left side, we're going to have modulus of 3 in brackets 5 over 3 minus 1. Okay, what do I get inside here? I'm going to get, okay, this cancels out. I'm going to have 5 minus 1, which of course will give me 4. So what it means that this solution here is valid. Okay, again, we can also substitute this one there, all right, to check to see if it's actually correct. Okay, so we're going to have modulus of 3 in brackets negative 1 minus 1 is equal to modulus of negative 3 minus 1 is equal to modulus of -4. All right, of course, modulus of -4, that will give me 4. So, of course, that shows me that both solutions that we are having here, that we got, x is equal to 5/3 and x is equal to -1, they are both valid. Okay, so those are our solutions. So that's what we need to do for 1A. And then now moving on to B, the question, as you can see there, is actually saying, hence, okay, using logarithms, solve the equation. So this word there, hence, it means, therefore, what it means is that whatever we got from the first, from the previous part of the question, we are supposed to apply it here. Okay. So what we know is that x is equal to 5/3 and x is equal to -1. All right. So if I'm to compare the equations in these two parts, this one here and that one, of course I can see, okay, let me write it close by there. I'm having 3x minus 1 is equal to what? Is equal to 4. Right, but if I'm to compare this, I see that x is substituted by what? 5 to the power of y. So which means our x is actually 5 to the power of y. That's what it basically means. So I'm going to continue, of course, saying 5 to the power of y is equal to what? 5/3, or 5 to the power of y is equal to -1. That's what it means. Okay, because that's actually the ends part. We don't necessarily need to apply the definition again in trying to solve the equation. We just have to start from where we ended on the first part there. So now, of course, applying logarithms, as they are saying there, we can apply logarithms on both equations, this one here and that one. So if I have log of 5 to the power of y is equal to log of 5 to the 5/3, okay. And then, of course, for me to get to solve for y, I need to apply power law here. I'll bring down the power. What am I going to have? I'm going to have y log of 5 is equal to log of 5/3. All right, of course, we have to divide both sides by log 5. So I'm going to get y is equal to log 5/3 divided by log 5. That is equal to, now I have to use the calculator there. Log of 5/3 divided by log of 5, what do I get? I'm going to get 0.37 0.31739 and so on. Of course, I can't continue writing everything that is on the screen. Now if I round off that to 3 significant figures, that will give me, because remember, to 3 significant figures, we start counting from here, 1, 2, 3. So now you see this is 3 is less than 5, so it doesn't affect this number here. So all we need to have is 0.317. That is 3 significant figures. Okay, so that is for 5 to the power of y is equal to 5/3. Now for this one here, as we can see, of course, that 5 to the power of y is giving us -1. We know, of course, that there is no number that you can raise to the power of 5 to get a negative number. So this statement itself is actually invalid. Okay, so we can just end there. We just have to write invalid. All right. Okay, it's important, of course, to indicate that this statement here is invalid, because even if you try to continue to apply logs, you will see that if you apply your logs on both sides, you're going to have y, you're going to have log of 5 to the power of y is equal to log of a -1. Now, remember, there is no log of a negative. Okay, we can't have a log of a negative. That's actually the issue here. Even if you look at the graph of a log, Let me use a different color. If you look at the graph of log, this is how it is like. That's the x-axis, the y-axis. The graph of log goes like this. Okay, so we don't have the negative. It's actually just positive, as you can see. All right. So that's where we are now. Actually, log of a negative, even if you try to punch that on your calculator, you'll see that log of a negative is invalid, or it actually gives you math error. Okay. Now in question number 2, it says solve the equation 2e to the power of 2x minus 17 e to the power of x plus 8 is equal to 0, giving your answers in the form of x is equal to a ln of 2, where a is a constant. All right, if you look at this question here, or this equation, it's actually a disguised quadratic equation. All right, so if you manipulate it like this, if you have 2 e to the power of x, all right, that's to the power of 2, which is the same as e to the power of 2x there. So minus 17 e to the power of x plus 8 is equal to 0. If I substitute e to the power of x, I will end up having a quadratic equation. All right, so let's say let y is be equal to e to the power of x. Let me not use x, okay, because otherwise there will be a conflict with the x which is there already, which is a variable that we are looking for. All right, so I would rather use another variable, which is what? Y. So I'm gonna have here 2y squared minus 17y plus 8 is equal to 0. All right, so that's the equation that I'm having, and you can see that's actually a quadratic equation. So just by a simple substitution, we see that we can convert that into this. So with that equation there, we can solve it. All right, either by factorization or by completing the square or formula method, but it wouldn't be wise to use completing the square because it's actually a complicated method on its own. So I think by factorization that would be easy. If we multiply this 2 here by 8, what do I get? I'm gonna get 16. All right, so and then what are the factors of 16 that if we add them up we will get negative 17? That should be negative 1 and negative 16, because you see negative 1 times negative 16 will get 16, but negative 1 plus negative 16 will get negative 17. So that's actually what we need here. So with a shorter method, we'll just say y minus 1 in brackets y minus 16 is equal to 0. But since this here we have a coefficient 2, the coefficient of y squared is 2, so we can divide each part there by 2. So I'm gonna have here divide by 2, divide by 2. Okay, so what am I having here? I'm having y is equal to negative y minus half in brackets y minus 8. That's 16 divided by 2 is equal to 0. So I'm gonna get, to solve that, it means that these two factors here could be 0, because the product of the two is equal to 0. So it's either this is equal to 0 or that equal to 0. So I'm having y minus half equal to 0, or y minus 8 equal to 0. So what do I have for y? Y is going to be equal to half, or y is equal to 8. All right. Now, remember, we are not solving for y. Y is actually a variable that we just introduced ourselves. We need to go back to what we need to have there. So what it means actually is that, remember, y is equal to e to the power of x. So our solutions here are for e to the power of x. So I'm actually having here e to the power of x is equal to half, or e to the power of x is equal to 8. All right, so if I apply ln on both sides, I'm trying here to make sure that my solutions are actually in the form that is required. Okay, I'm gonna have x is equal to ln of 0.5, that's half, okay, or x is equal to ln of 8. Here, remember my solutions should be in the form of ln of 2. So I need to make sure that I have 2 here. So I think it's better for me to take 2 to half there instead of 0.5. Okay, we erase this part here. Of course, my solutions are actually correct, but I should leave my solutions in the form that they require, which is a constant, ln 2. So I will say here x is equal to ln of half. Okay, but 1 over 2 is the same as 2 to the power of negative 1. So I can have it what, ln 2 to the power of negative 1. So if I bring down using the power law, that will become negative 1 ln of 2. And of course, if you compare that with what we have there, that will actually be fine. Okay, now with the other one, what do we have? We have x is equal to ln 8. I can write 8 in exponential form, which is 2 to the power of 3. And if again I bring down the 3 using the power law, I'm going to have x is equal to 3 ln of 2. Okay, so you see both of my answers are actually in the form that is required here. A, which is a constant, ln of 2. So here, negative 1 ln of 2. Here, 3 ln of 2. So those are the solutions that I'm actually required to have. Yeah, now looking at question 3, the diagram shows part of a curve whose equation is y is equal to 2 sine squared x plus 7 sine x plus 3, where x is measured in radians. And the curve crosses the x-axis at point A, that's what you see there, and the shaded region is bound by the curve, and the lines x is equal to 0 and y is equal to 0. Okay, so that's x is equal to 0, that's y is equal to 0, and of course the curve. So the shaded part there is what we are interested in. So the first thing that they are saying there on the first part is find the exact x-coordinate of A. So we want this x-coordinate, the x-coordinate for the point A there. Now what we know, of course, is that this line here, its y is equal to 0. So along that, the x-axis, the value of y is 0. Okay, so for us to get that, all we need to do is to substitute in this equation here, we substitute y to be 0, and then we solve that trigonometric equation. All right, so let's have it. So we're gonna have 2 sine, okay, we're gonna have 2 sine squared x plus 7 sine x plus 3, that is equal to 0. Okay, so looking at that equation there, we see that that's actually a disguised quadratic equation. So what I could do is that I could actually say, maybe say z be sine x, okay, and let z be equal to sine x. Now I'm avoiding using y because of course there's a y already which we substitute to be y, to be 0. Okay, so it's better I use another variable like z or any other. So what am I going to have here? I'm going to have 2z squared plus 7z plus 3 is equal to 0. So that's a quadratic equation there which we can easily solve either by formula method or completing the square or factorization. But of course we need to be wise. Remember, this is just 2 marks. We can't go ahead and use maybe the formula method, which is a bit long, and completing the square. So the easiest thing there is to actually factorize, because this is factorizable, If you multiply 3 times 2, you are going to get 6. Okay, I'll use this space here. And what are the factors of 6 which can give 7? So that's 1 and 6. All right, so what we are saying here is 1 times 6, we get 6. 1 plus 6, we get 7. All right, so straight away, what am I going to have? I'm going to have z plus 1, z plus 6 is equal to 0. But remember, the coefficient of z squared here is 2, so we divide each number here by what? By 2. So we can have divide by 2 there, divide by 2. So what I'm actually having is z plus 0.5 in the first bracket. In the second bracket, we have z plus 3 is equal to 0. All right, so solving this equation, what it means is that, remember z, our solutions for z, there is negative 0.5 or negative 3. All right, remember, it's either this factor here is equal to 0 or that is equal to 0. So if we solve, we'll get z is equal to negative 3 or negative 0.5. But remember, z is representing what? Sine x. So if I'm to have it, I'm having sine x is equal to negative 0.5 or sine x is equal to negative 3. Now look, this here is invalid. Why is it invalid? It's because you know that sine x, the function of sine x actually ranges from negative 1 to 1. So we can't have it as equal to negative 3. So that's actually invalid there. So what we are interested in now is this part here. Sine x is equal to negative 0.5. Now remember, sine x, if we use looking at the CAS diagram, sine x is only negative in the in the third and fourth quadrant. Okay, so but the first thing is to get the basic angle. What is our basic angle? Inverse of sine of 0.5. That gives me pi over what? Pi over 6. Okay, so in the third and fourth quadrant. So what are we going to have then? We are going to say sine x, in the third quadrant, we are going to have x is equal to pi plus pi over 6. And of course, in the fourth quadrant, that will be 2 pi minus pi over 6. But if you look at this diagram here, we want the smallest value of the two. So we are not interested, of course, in the one for the fourth quadrant. So all we want is this pi plus pi over 6. So what does that give us? I'm going to have pi 6 pi over 6 plus pi over 6, which gives me 7 pi over 6. That is actually the exact answer that I want. Now, if we are talking about the exact, which means we don't have to convert this one to decimal, all right, that should just be in pi form like that. That's actually exact, okay, in fraction form or in pi form. All right, then we move on. So that is actually what we need there for part A. We move on. The question now says find the exact gradient of the curve at A. Okay, we want the exact gradient of at this point here. So remember, the first thing that we need to do for us to get the gradient, we need to differentiate this. And if we differentiate that, what we are going to do is to substitute the value of x there. All right. So what are we having here? We have y. With y is equal to 2 sine squared x plus 7 sine x plus 3. All right, so to substitute that, I'm going to differentiate that. Can we use f? So we are going to have f prime of x use the notation f prime x. Now, please take note that this here is a composite function. All right. And if we are to differentiate that, we use the chain rule. Okay. So that will be the constant multiplied by inner derivative multiplied by the outer derivative. So what is our constant there? Our constant is 2. So we have 2 multiplied by the inner derivative. Our inner function in this case is sine x. So if we differentiate that, we are going to get cos x. So our inner derivative is cos x multiplied by the outer derivative. So if we differentiate sine squared x, what are we going to get? We are going to get 2 sine x. Okay. Right, because we've already differentiated the inner function, which is sine x. All right, so that's what we are going to have here. And then differentiating this part here, that will give us 7 cos x. And of course, the derivative of 3 is 0. All right. Now, simplifying that further, what are we going to have? We are going to have 2 cos x times 2 sine x. That will give us 4 sine x cos x plus 7 cos x. So that is actually our derivative, the general gradient of that curve there. All right. So, but what we want is just the gradient at point A. Okay, of which at point A we know that x is equal to 7 pi over 6. So the gradient, then we just need to substitute that 7 pi over 6, okay, is equal to, we need to show the substitution, 7 pi over 6 cos of 7 pi over 6 plus 7 cos 7 sine, is it cos? Okay, of 7 pi over 6. So we need to use a calculator here. We need to use a calculator to get our answer. And of course, as you use your calculator there, please take note that we need to convert, because our angles there are actually in radians. So we need to convert the mode of our calculator into radians. Please don't forget that. All right. So plugging that into the calculator, we get -5 square root of 3 over 2. Okay, that's -5 square root of 3 over 2. That is actually the exact gradient, and remember, it's exact, so we don't need to convert this one into decimal form, so we leave our answer as that. All right. Now moving on to integration, the third part of the question there. By expressing 2 sine squared x in terms of cos 2x, find the area of the shaded region. All right, now I want you to remember here that for us to get the area under a graph, remember what we need to do. We need to integrate this. So we are going to integrate this part here. But to integrate this expression here, we can't integrate sine squared x as is. So what we need to do is, of course, we need to write this in terms of the double angle of cos. So you need to apply or use the double angle. Of course, it's there in your formula sheet. All right. So you convert it into cos 2x as they are saying there. That's actually the tip that they are giving us there. So instead of integrating this, first of all, we need to convert it into that. But what does the double angle say? Cos 2x, we know it is equal to 1 minus 2 sine squared x. So we need to manipulate this, make this one the subject of the formula. So if I take this one here to the left-hand side, what do I have? I'm going to have 2 sine squared x, so that it becomes positive. And of course, taking cos 2x to the other side, I'm going to have 1 minus cos 2x. Okay, so that's simply what we need to do here. We have made 2 sine squared x the subject formula. So that's the first part of the question. And then, of course, we can continue. Instead of integrating this, we are going to integrate that, which is, of course, easy. All right. So remember, the area under the graph, our limits are from 0 to 7 pi over 6. Remember, the value of x at a is 7 pi over 6. All right. So we are integrating y, of course, that with respect to what? To x. Now, our function, we have 2 sine squared x, all right, plus 7 sine x plus 3. That's what we need to integrate there, of course, with respect to x. But since we have said 2 sine squared x is 1 minus cos 2x, so that's what we are going to have there. 0 up to 7 pi over 6. So we have 1 minus cos 2x plus 7 sine x plus 3 dx. All right. But this can actually be simplified further. Remember, these constants, 1 plus 3, that can simplify to 4. So it's better to, first of all, have it like that. 7 pi over 6. So 1 plus 3, which is going to give us 4. Then minus cos 2x plus 7 sine x. Okay. So then to integrate that, what are we going to have? The integral of 4, that will give me 4x. All right. And then the integral of cos 2x, this here is a composite function. So if I'm to integrate it again, I have to use chain rule. Now remember, the integral of the composite function is going to be 1 over the inner derivative multiplied by outer integral. Now our inner function here is 2x. So if I differentiate that, I'll get 2. So which means I'm going to have, okay, minus 1 over 2, which is the inner derivative, multiplied by the integral of cos 2x itself. That will give me sine 2x. Okay. And then, of course, then the integral of 7 sine x here, we're going to get plus 7 cos, minus actually. We get negative 7 cos x. Remember, the integral of sine is actually negative cos x. Okay. So that's what we are having there. So, of course, we put our limits there from 0 to 7 pi over 6. So what we now need to do is to substitute the upper limit, okay, first. So in the first bracket, what are you going to have? We are going to have 4 multiplied by 7 pi over 6 minus 1 over 2 sine of 2 times 7 pi over 6. That will give me 7 pi over 3. Okay, minus 7 cos of 7 pi over 6. So that is what is going to be in the first bracket. And then minus, substituting the lower limit now, that will be 4 times 0 minus half sine of 2 times 0, that will give me 0, okay, minus 7 cos of 0. Okay, Now simplifying the first bracket now, this first bracket here, what are we going to get? What are you going to get if we simplify this part here? That will give us 14 pi over 3, okay? That's what we are going to have here. Minus this part here, half of sine of 7 pi over 3. We try to use our calculator. That's sine of 7 pi over 3. Okay, that will give us square root of 3 over 4. All right, minus 7 cos 7 pi over 6. All right, what we have there, we have cos of 7 pi over 6. We are plugging that into our calculator. All right, of course, that times 7. That will give us negative, so that making this one to be positive. 7 pi over 3. 7 times square root of 3 over 2. That's what we are having. All right. So that's in the first bracket, minus 4 times 0, that gives us 0. And of course, sine of 0, it's 0 also. This part here, cos of 0 is 1. So 1 times negative 7, what are we going to get? We are going to get negative 7. Okay. So simplifying all that. So area in that case becomes 27.2899. Of course, and so on. But to 3 significant figures, that should become 27.3. All right. So that's what we are having there. All right. So yeah, we move on to question 4. So looking at question 4 now, the polynomials f of x and g of x are defined as what is shown there. F of x is equal to x cubed plus ax squared plus b, and g of x is equal to x cubed plus bx squared minus a, where a and b are constants. Now it is given that x plus 3 is a factor of f of x. It is also given that when g of x is divided by x plus 1, the remainder is 6. All right, so the first part of the question is find the values of a and b. Now, we are to find two unknowns here. So definitely what we need to do is to have two equations. We need to create two equations which we are then going to solve simultaneously. So the first equation, we can get it from this fact here, where we are told that x plus 3 is a factor of f of x. All right. So to have that, remember our factor theorem, we are having here f of x is equal to x cubed plus ax squared plus b. So if x plus 3 is a factor, it means we are having here x plus 3 is equal to 0. We find the value of x, which is negative 3. So if we substitute f of negative 3 into that expression there, of course, according to remainder theorem, we are supposed to get 0. Okay. So let me substitute an x is equal to negative 3 in that, and of course equate that to 0. So I'm going to have here negative 3 to the power of 3 plus a negative 3 squared plus b is equal to 0. So simplifying that, that gives me negative 27 plus 9a plus b is equal to 0. So my first equation simplified, 9a plus b is equal to, I'm going to take negative 27 to the other side. I'm going to get 27. So that's my first equation. All right. So I'll also create again another equation where we are saying if we divide g of x by x plus 1, the remainder is going to be 6. So for x plus 1, we need to get the value of x there. So the value of x is equal to negative 1. So again, I'm going to substitute g of negative 1. Okay. And I should expect to get what? 6. That is actually the remainder theorem. Okay. So we are having here negative 1 to the power of 3 plus a negative 1 squared plus, that should be b here. We're having negative 1 because our g of x is x cubed plus bx squared minus a. So we're going to have b in brackets negative 1 squared minus a. That should be equal to 6. So if I simplify this, remember, negative 1 to the power of 3, that gives me negative 1 plus negative 1 squared, that should be 1 times b, that will give me b minus a is equal to 6. So simplifying this further, I'm going to get b minus a equal to negative 1 goes that side, I'm going to get 5. All right. So now I need to solve. Okay, so this is my second equation. Now from these two equations here, I need to solve them simultaneously to get a. So I think the best thing would be to use, okay, let me eliminate b. Okay, I need to eliminate b. So it's this equation here minus equation 2. So that's what I'm actually having here. Equation 1 minus equation 2. 9a minus negative a. That will give me 10a. Okay. And then b minus b. That should be 0. So b has been eliminated. Equal to 27 minus 5. That should be 22. Okay, so that is going to give me 22. All right, so that's what I'm having here. So my a is going to be equal to 22 divided by 10, which of course is going to be 11 over what? Over 5. All right, so to get my b, what am I going to have? I'm going to have b is equal to 5. So I'm taking a to that side, which is plus, which is going to be plus what? Plus a. Now, of course, I know what is a. So we have 5 plus 11 over 5. Okay. Simplifying that, I want to make the two of them to have this one also to be a fraction. So that will be 25 over 5 plus 11 over 5, which gives me 36 over 5. So that's the value of a there, 11 over 5, and the value of b, it will be 36 over 5. All right. Now looking at question B, the B part, we are told here that when a and b are these values, of course, the values that we got now in the first part, find the smallest possible value of g of x minus f of x as x varies. All right. So we will have to have my g of x here. Remember g of x, our g of x is x cubed plus bx squared minus a. That's my g of x. So that minus f of x, which is x cubed plus a x squared, all right, plus b. Now, if I were to simplify this, I can see that this will cancel out because it's x cubed minus x cubed, so that will cancel out. So I'll actually remain with a kind of a quadratic expression. So what am I going to have? I'm going to have bx squared, of which, what is my b? My b is 36 over 5x squared, all right, minus a. What is my a? My a is 11 over 5, all right. Okay, so that's what I'm having here, minus my a, x squared, which is 11 over 5 x squared, plus b, which is 36 over 5. All right. So we need to simplify that. This part here minus that. So it's 36 over 5 minus 11 over 5. That should be 25 over 5. So 25 over 5, which is 5. So we have 5x squared. All right. And then negative 11 minus 36, negative 11 over 5 minus 36 over 5. Of course, that should become, that should give me negative 47 over 5. That should become minus 47 over 5. Okay. So the question here is find the smallest possible value of this. Now, if you look at this, this is actually kind of an expression that is actually in a completed square form. Okay. So the y value of that is the smallest possible value of this. So this is actually the smallest possible value of x. So we have actually the smallest possible value is negative 47 over 5. Please take note. What we are saying here is that 5 can, this expression here can be written as 5x plus 0 squared minus 47 over 5. Okay, so it's like in completed square form. So we can easily get the turning point here. Our turning point will be 0, negative 47 over 5. So the y value which we need for the smallest possible value is actually this one here, negative 47 over 5. So that's why we are considering this. All right, so that's what we are having there. Now, looking at question 5, the equation of a curve is y is equal to 6x e to the power of 1/3 x. And it is said that at the point on the curve with x coordinate p, the gradient of the curve is 20. Show that p is equal to 3 ln, in brackets, 10 over p plus 3. All right. So what we basically need to do there, since we're talking about the gradient of this function here, we need to differentiate this function. Now, when we differentiate that function, we then substitute the derivative as to be 20. So because the gradient is given as 20 when the x-coordinate is p. So let's start by differentiating this function here. But now I want you to see that this function here is a product. There are two parts here. There is this part here, 6x, and then there's also another one which is e to the power of 1/3 x. So those are two factors that we can differentiate separately, differentiate as a product. Okay, so let's have it. I'm having y is equal to 6x e to the power of 1/3 x. So if I differentiate that by parts, what am I going to have? Okay, this, can I use the notation f prime x is equal to, if I start differentiating 6x, that will give me 6. Of course, this one here, it will remain as is, e to the power of 1/3 x, all right, plus, now I'm going to hold this one constant as is, and then I differentiate e to the power of 1/3 x. What am I going to have? I'm going to have 6x multiplied by 1/3 e to the power of 1/3 x. Now remember that this is actually a composite function, so its inner derivative, which is 1/3, multiplied by the outer derivative, which remains as is. Okay, so if I simplify that, what am I going to have? I'm going to have 6 e to the power of 1/3 x plus 6x times 1/3, that will give me 2x e to the power of 1/3 x. Okay, that of course is our derivative. Now what we are told here is that the gradient is 20 when x is equal to p. So we are going to substitute x with p, and then of course here we substitute our 20. That's what we are going to have here. We have 20 is equal to 6 e to the power of, let me write 1/3 x as p over 3 plus 2p e to the power of p over 3. All right. So with that, I'm sure you can see that we can actually divide throughout by 2. Why am I saying so? Because I need to have some 10 in what way I want, where I'm driving to. Okay, so if I divide throughout by 2, what am I going to have? I'm going to have 10 is equal to 3 e to the power of p over 3 plus p e to the power of p over 3. All right. Now, as you can see, in what we actually, where we are driving to, we need to make p the subject of the formula, and e has to disappear. So we are going to try and in this case here, we can factor out e to the power of p over 3, and then we solve for p. Okay, that's what we are trying to do. All right. So we have 10 is equal to e to the power of p over 3, in brackets we have 3 plus p. Now we divide both sides by the bracket. We're going to have 10 over 3 plus p is equal to e to the power of p over 3. All right. Now, so we have to now solve for this p here, because as you can see that there's ln. So if we apply ln on both sides, this side here we are going to have p over 3. Okay, let's apply p ln on both sides. So we're going to have ln of, in brackets, 10 over 3 plus p, okay, in brackets is equal to ln of e to the power of p over 3. All right. So if we have then have p over 3, ln of e is actually 1, remember? So we're only going to remember is have p over 3 equal to ln of 10 over 3 plus p. Okay. So if we multiply both sides by 3 there, we're going to have p is equal to 3 ln of 10 over p plus 3. Yes, of course, this is actually what we want to show. Okay. Now, in the next part of the question, they're saying show by calculation that P is lying between 2.0 and 2.2. What we are basically saying here is that, or the approach that we are going to use the method of sign change analysis. So if we substitute P into the function for this one and that one, and we are getting different signs, then it means P is lying between these two. And we call that method sign change analysis. All right, so what is the function that we are having here? So obviously our f of P is going to be, what we are saying is we have to take this one here to this side, so we're going to have P minus that. So you're going to have P minus 3 ln of 10 over P plus 3. Okay, so we need to substitute. If we substitute, if we have f of 2, we see the sign, is it positive or negative, and then f of 2.2, we compare the signs. If there is a positive and a sign and a negative, then it means the P is lying between 2.0 and 2.2. So let's get f of 2 first of all. F of 2.0. So we have 2.0 minus 3 ln of 10 over 2.0 plus 3. All right, what are we getting? If we use our calculator, we have 2.0 minus 3 ln of, in brackets, 10 over 2.0 plus 3. Okay, so if we punch that into our calculator, we get negative 0.079. That's to 3 significant figures, to 2 significant figures. So that is less than 0, it's negative. What about if we substitute 2.2? What are we going to get? 2.2 minus 3 ln of 10 over 2.2 plus 3. If we substitute that, okay, we're gonna get positive 0.038. now, which is actually positive, so it's greater than 0. So therefore P lies between 2.2 and 2.0 is of course what we have to show there. Okay, so that's what we're actually having there. We need to make sure that we show the substitution here, and of course we need to indicate that this is less than 0 to say that it's negative, greater than 0 is positive, and of course you always need to make sure that you give us the conclusion, which is this one here. All right, and then the next part of the question, the question is saying use the iterative formula. Okay, there is the iterative formula already, it's derived for us, with P1 being 2.1 to find the value of P correct to 3 decimal places. Give the result to each iteration to 5 decimal places. So each result at each iteration we should leave to 5 decimal places. Now we are only going to stop if we have 3 consecutive iterations, which to 3 decimal places are going to be constant. All right, so what are we going to do here? We already got our P1, so the next thing is to find P2. So if you can find P2, we are substituting P1 as 2, 1. All right, so we have 10 over 2.1 plus 3. What are we getting? We have 3 ln of open bracket. All right, we have 10 over 2.1 plus 3. Okay, the closing bracket there. So we are getting 2.0200 That's to 5 decimal places. So that's the first iteration. Then our P2, our P3, we now need to substitute this again there. So we have 3 ln of 10 over 2.02003 plus 3. What are we getting? So here we're going to get 2.06744. Okay, to 5 decimal places, so that should be 5 there. If you write that to decimal places. Now, but we can't continue writing, obviously, doing the substitution like this, because writing a number to 5 decimal places, obviously, it's going to take us a long time. So all we need to do now is to plug in there. What are we going to plug into the calculator? We're just going to say 3 ln 10 over, so in place where you're supposed to substitute, you just write answer, okay, plus 3. So the way you see it there is what you are going to, because obviously the answer that you actually that you have calculated, the calculator saves it. So all you now need to do is to plug in this 3 ln of 10 over answer plus 3. So you have to make sure that you actually put the answer. So to access answer, you need to go to alpha first, and then you press answer. Okay. So then the next thing that you need to do is just now to write down your p-values. So P4 is going to be 2.03924. Okay, so we can find P5 just now by pressing equal to. You don't have to now retype everything. Okay, so the next one, P5, is 2.05599. Okay, P6, press equals 2.0460. For P7, that's gonna be 2.0519 P8, press equals to 2.0484 3. P9, 2.05052. P10, it's gonna be 2.04928. Okay. P11 is gonna be 2.05002. P12 it's going to be 2.04958. P13 is gonna be 2.04983. P14, so it goes on, you can go on 2.04968. Now what I want you to see is that for the last, maybe say starting from P9 going further, you see that to 3 decimal places this number is going to be 2.050. okay, and the second one here again to 3 decimal places is gonna be 2.050. P11 it's 20.50. P12 is 2.0 to 3 decimal places, that will still be 0.50. To 3 decimal places, the same also here, that will be 2.050. So as you can see, that actually now the number to 3 decimal places, it is remaining constant, and which means our P then to 3 decimal places is going to be 2.050. okay, so you actually have to continue doing the iterations till you see that maybe to the required decimal places your number is remaining the same. Okay, now we look at question 6, which is actually on trigonometry. The question is express 2 sine theta plus square root of 5 cos theta in the form of r sine in brackets theta plus alpha, where r is greater than 0 and alpha of course is between 0 and 90 degrees. Now this, we call this r formula. So all we need to do is to expand this one here, that's compound angles. We expand this one and then we compare the coefficients of sine theta and cos theta. All right, so we will take this as we are saying r sine theta plus alpha, okay, that is identical to 2 sine theta plus square root of 5 cos theta. All right, so if we expand this side, this is what we are going to get. We are going to get r sine theta cos alpha plus r sine alpha cos theta. All right, of course still identical to 2 sine theta plus 5 cos theta. Right, if we want to find r here in this case, what we, okay, let's first of all maybe try to get our cos alpha, our alpha rather. So what are we going to do here? We compare the coefficients of cos theta. So if we, let's start with sine theta. We compare the coefficients of sine theta. We're going to have r cos alpha, okay, because the coefficient of sine theta here is r cos alpha. On the other side here, what do we have? We have 2. So that is going to be equal to 2. So that gives me equation 1. I do the same also, the coefficient of cos theta. In this case, this is going to be r sine alpha. Okay. For cos theta, we're saying we have r sine alpha. We can see that there. Okay, cos theta, this is our coefficient r sine alpha, equal to, on the other side here, the coefficient of cos theta is square root of 5. Okay, so that's equation 2. Now, for us to get our cos alpha, you see that if we divide equation 2 by equation 1, the r will cancel out, and sine alpha over cos alpha, that will give me tan alpha. That should be equal to square root of 5 over 2. Okay, so that's what I'm going to have here. If we divide equation 2 by equation 1, we're going to have sine alpha over cos alpha is equal to square root of 5 over 2. All right, just to save space, let me continue in the same line. I'm going to get tan alpha is equal to square root of 5 over 2. So what is alpha then? That should be inverse of tan of square root of 5 over 2. Okay, what do we get? Our alpha. So for tan, we are saying here inverse of tan square root of 5 square root of 5 over 2 what are we going to get? We're going to get 48.189. Okay, 1.9 rather, to 2 decimal places. Okay, so that's our alpha. Now for our r, what we know, of course, there in this case, that should be, because what is going to happen is that if we were to square this one here and that one here, we're going to get r squared, r cos squared alpha plus r sine squared alpha. So remember, cos squared alpha plus sine squared alpha, that gives us 1. So we can factor out r squared. So since we squared this side, we should also square both sides. So we are squaring equation 1 and we square also equation 2, and then we add them. At the end, we will find that our r is going to be equal to square root of 2 squared plus square root of 5 squared. That's what we are going to have here. So which gives us what? 4 plus 5. So which of course comes to what? Square root of 9, which is 3. So that's what we are having there. All right. So meaning to say that at the end, of course, there isn't enough space, mainly because of my handwriting, but otherwise the answer, because the question here is that what are we asked to do here? They are saying give the value of alpha correct to 2 decimal places. Oh, okay. So all we needed to do was to find the value of alpha. Not necessarily we didn't necessarily need to find the value of r, of course. But that is obviously going to be needed in the next part here. Why? Because what we are going to do is that, first of all, we need to write this in the form of that. Now, remember our r is 3. Okay, sine theta plus 48.19. That here is the same as this one, because that's what we have done in the second part, because this is actually a hence question. So it means what we got in the first part, we are going to use it here. Okay, so this here is going to be equal to 2.4. All right. So that's what we are having here. So that's the equation that we need to solve. So definitely what we need to do is the first thing is to divide both sides by 3. So you're going to get sine theta plus 48.19 to do this is equal to 2.4 divided by 3. That will be 0.8. Okay. Now solving that, we don't want a complicated part of this, especially this bracket here. So let's say maybe the bracket is equal to y. So we could say let y be equal to theta plus 48.1. All right. what it means is that even this range here is also going to change. So our new range should be from 48.19, because since theta is added 48.19 here, that should happen even there. So we have 48.19 to 360 plus 48.19. So that we should take care of that when we are now using the CAS diagram. So let's just say we're trying to solve here. Sine y is equal to 0.8. All right. So what then is the key angle here? The key angle is inverse of sine of 0.8, which is, okay, I need to use my calculator there. That gives me 53.13. 53.13. All right. Now with that, what then are we having here? This is my key angle, but remember sine y is positive 0.8, which means according to the CAS diagram, we are talking about the first quadrant and the second quadrant. Okay, so this is where we are, in the first there and there. Those are actually the two quadrants that we have to consider. So in the first quadrant, we could say y is equal to what? 53.13. All right. And then in the second quadrant, we know that we are talking of y is equal to 180 minus the basic angle, which is 53.13. What does that give us? That will give us 126.87. It is important here to make sure that our angles that we give for now to take 2 decimal places. Even the key angle, it should be to 2 decimal places, because our final answers should be to 1 decimal place. So to cater for any error there, we need to make sure that we leave to a higher degree of accuracy. Okay. All right, so with that, having that, now remember we are not looking for y, because these values here that we got for the first quadrant and for the second quadrant, those are for y values, but what we are looking for is theta. So we now go back to use this. So we are now saying theta plus 48.19 is equal to 53.13 and 126.87 degrees. So theta, what are you going to have? Our theta is then going to be 53.13 minus, because we are solving now for theta, so 48.19 goes that side. So it's 53.13 minus 48.19. 53.13 minus 48.19. What we get is our angle. We get 4.94. Okay, I get 4.94, which of course to 1 decimal place that becomes 5.0 degrees. Okay, and then the second one, for this one here, we still say 126.87 minus 48.19. What do we have? 126.87 minus 53.13. What do we get? We are going to get 73.74 degrees. Okay, so those are our solutions for that equation there. All right, so what we basically did there was, instead of dealing with this bracket, continuously writing this bracket, it's better to replace it with y. But before we did that, of course, I'm sure you know that from the first part of the question, we noticed that this here could be written in this form, in the R formula. All right, so where our R is 3 and our alpha, of course, we got it there, is 48.19, and we equal to 2.4. So we solve that. First thing is to divide both sides by 3, and we got that. But to avoid working with the bracket, we replace that with the bracket with y, and that's what we did here. And so then it becomes a simplified trigonometric equation. First thing, we get the basic angle, and that's what we got there. And of course, we realize that that sign is positive, so that should be in the first quadrant and the second quadrant. So first quadrant, we know y is equal to 53.13. Second quadrant, that should be 180 minus basic angle, which is that. Then, of course, we can go back to deal with theta, to find our theta. So we bring in our theta in place of what? Of y. So, of course, getting these as our solutions. This one here to 1 decimal place, that should be 73.7. Okay, that is actually our answer there. Okay, to 1 decimal place. All right, so that's what we have there. Now, then the next part of the question, what is it saying? Saying state the greatest and least values of that. Now, it is important, of course, to know why we convert expressions like these ones here into our formula. Maybe I just need to talk about this. If we're having an expression like this, and they say we should convert it to that, the reason why we are doing that is, of course, to try and be able to solve an equation like what we are having here. It was going to be difficult for us to solve an equation like this one, especially with the fact that we are having two variables, which is sine and cos. So we can't solve an equation, it's actually difficult to solve an equation with two trigonometric ratios. So we need to convert to one trigonometric ratio. So that's one way of doing that, converting these two into one using the RR formula. But the other thing also, the other reason why we need to convert this into that form, it is for us to be able to get the maximum and the minimum of the function of y is equal to this. Because we know, of course, that when we have something like this, this here gives us the maximum. That gives us the amplitude for the graph going up and going down. So the maximum, it should be positive, this. Minimum, of course, negative of this one here. Okay. So that's why even in this question here, they are saying state the greatest and least values of. So it's basically for the maximum, or should we say greatest, is, remember our R is what? Is 3. So that should be positive 3. And then the minimum, which is the least, it should be negative 3. Because remember, the graph has got a maximum and minimum. So we are saying that this is 3. Here, this is what? Negative 3. Okay. So now looking at question 7, we are told to show that cosec 2x plus cot 2x is identical to cot x. All right. So here we suppose, of course, to use the reciprocal identities, these two here. Remember cosec 2x, that's 1 over sine 2x, that's what it is, plus cot 2x, that's the same as cos 2x over sine 2x. Okay, so having done that, I'm sure you can see that this on the right hand side is actually a single term. So we should make these two as a single fraction, rewrite this as a single fraction. What are we going to have here? We're going to have sine 2x. Remember, the denominators are already the same, so all we need to do is to add up the numerators. So it's 1 plus cos 2x. Now here we need to remember that cos 2x it is actually equal to 2 cos squared x minus 1. So if we, because we want to make 1 plus cos 2x the subject of the formula, so it means we just need to take -1 here to this side. So what are we going to have? We're going to have 2 cos squared x is equal to cos 2x plus 1. So that's the identity that we need to use there. All right. So what then are we going to have? So on the numerator, instead of writing 1 plus cos 2x, that is going to become 2 cos squared x over sine 2x. This sine 2x here, remember, it is what? 2 sine x cos x, the double angles. Okay, so that cancels out. One of the cos x here cancels with this one here, so we remain with cos x over sine x, which of course becomes cot x. All right, so that is what we are having there on the A part. Okay, now the B part, the question now is find the integral of this. Now it's always important every time when you see questions at this level here, if this is question A and that is question B, normally there may be some relation that are actually there, so you may take it as if it's an hence question. Okay, now because if we look at this part here, what is inside the bracket, because we are to integrate integral of sine 2x in brackets cosec 4x plus cot 4x brackets dx. That which is inside the bracket, you can actually relate to this, to what we are having here. Okay, you can relate it to this. Remember, if we have cosec 2x plus cot 2x is identical to cot x, it then means that cosec 4x plus cot 4x, that should be equal to cot 2x. Okay, maybe I should just write them close by together so that you can see the relationship. We are saying cosec 2x plus cot 2x we are saying it is identical to cot x. All right, so meaning to say that if we have cosec 4x plus cot 4x, that also means that we are going to have what? Cot 2x. Okay, that's actually what we are having here. We just, you see here, if we have a double angle here, there and there we have a single angle. So it means if we have a double angle here, which is 4, then down here, which means it's supposed to be what? It's supposed to be 2. So what we're actually saying, instead of integrating this, we can simplify the bracket to that. So what then do I have? I'm going to have integral of sine 2x. The bracket now becomes what? Cot 2x. Okay, we're integrating with respect to x. So of which cot 2x, that is actually cos 2x over sine 2x. All right, so what are we saying here? We have sine 2x multiplied by cos 2x over sine 2x with respect to x. So this cancels out. Okay, sine 2x, it cancels out with that. So a simplified expression that we need to actually integrate would then be integral of cos 2x. So all we need to do is to simplify this expression which we are supposed to integrate. But that's a complicated expression, trigonometric expression to be integrated. So we need to do this, simplify this, obviously using the understanding of what we got from the first part. We simplify it to come to that. Now when it's like this, then that becomes easy because that's a composite function here. Remember, for a composite function, integrating that, it will be 1 over inner derivative multiplied by outer integral. So we are having here our inner function is 2x. So if we differentiate it, we get 2. So we are going to get 1 over 2. All right, that's our 1 over inner derivative multiplied by the outer integral. The integral of course is sine. So we are having sine 2x. Of course, that is plus what? Plus c. So simplified, that should be half of what? Sine 2x plus c. That becomes our answer. All right. So that's our question number 7 with 7 marks. So we move on to question 8. Now let's look at question 8, where we have, it is given that the integral of 3 over 3x minus 5 with respect to x, where the limits are from a to 2a, is actually equal to ln of 13 over 4. So what it means there is that if we were to integrate this and substitute these limits here, we are supposed to get this. Okay, but you see that our limits are actually in terms of a. So what we need to do there is to find the value of the positive constant a. So as we are saying, we integrate that, we substitute these limits. Of course, we equate to ln of 13 over 4, whereby we are going to have an equation, and that equation is what we need to solve. Okay. But first of all, if I could actually have a general understanding that the integral of k over ax plus b with respect to x, that is actually a composite function, of course, of a rational function. So the answer for that will be k, which is a constant, all right, this k here, multiplied by the inner derivative, multiplied by 1 over inner derivative. What is our inner derivative in this case? This is our inner function, the the denominator. So if we differentiate that, we get a. So we are going to get 1 over a multiplied by the integral of this 1 over, excluding, of course, the k, because the k is already there representing that. Okay, so we are now only looking at 1 over ax plus b. What is the integral of that? That is actually ln of ax plus b. Okay, of course, plus c. So simplifying that, we are saying k over a ln of ax plus b plus c. So that is the integral of a rational function, of which this is actually a rational function. So let's start by integrating that. So we are saying if I integrate that 3 over 3x minus 5, okay, with respect to x, what am I going to get? I'm going to get 3 over 3. All right, remember 3 is my constant, which is this one here, and the derivative of 3x minus 5 is 3. So it's 3 over 3 ln of 3x minus 5 plus c. All right, so if we now go back to this, remember this is actually a definite integral. This becomes 3 over 3, so we are only going to have the ln of 3x minus 5. So we are talking here of ln of 3x minus 5. We are no more considering the constant of integration, because this is definite integration from a to 3a equal to ln of 13 over 4. All right, so that's the equation that we are forming here. So we now need to substitute this. Okay, the limits, upper limit, okay, the substitute of the upper limit minus the substitute of the lower limit. So we are going to have ln of 3 times 3a, that gives me 9a minus 5, minus ln of, for the lower limit, that would be 3a minus 5, okay, equal to ln of 13 over 4. So that's what we are having here. We need to solve for x. This is actually a trigonometric equation. Now, for us to solve this trigonometric equation, we need to try and make this side here a single log also. All right, so that we can drop the logs. So we make a single log here, and since that side is also a single log, we can then drop the logs. So let's combine that. That's ln of 9a minus 5 over 3a minus 5. We are applying the quotient law. We are subtracting here, so that should be this over that. So it's ln of 9a minus 5 over 3a minus 5 is equal to ln of 13 over 4. All right, so then, since we have a single log here and a single log on the right hand side, we can then drop the logs. So let's do that. We're going to have 9a minus 5 over 3a minus 5 is equal to 13 over 4. So we have a fraction this side, a fraction this side. We can get rid of these fractions by cross multiplying. So we have that equal to that. All right, so let's have it. 4 times 9a minus 5, that will give me 36a minus 20 equal to, or let me not, for your understanding, let's have it. Let's not skip this step. 4 times 9a minus 5 is equal to 13 times 3a minus 5. What are you going to get? We are going to get 36a minus 20 equal to 39a minus 65. So solving this for a, if we take the 39a to this side, what are you going to get? We are going to get negative 3a is equal to 20 goes that side. We are going to have then negative 65 plus 20, which gives us negative 45. Okay. So if we divide both sides by negative 3, we are going to get a being equal to 15. Okay, so that's what we need to do there. Okay, it's an easy question. Now looking at question 9, the function f is given that is such that f of x is equal to log of x minus 3 base 2 for the domain x is greater than a, where a is a constant. Find the minimum value of a. Now the first thing that we need to understand there is that we cannot have log of a negative. So in other words, this bracket here, it should be greater than 0. Okay, log of a negative is undefined. Okay, so what we simply saying here is that x minus 3, which is the bracket, it should be greater than 0. That's what we are saying. So if we can solve that, we are going to have x is greater than what? 3. So now if we compare that with this domain that is given, x is greater than a, and here we have x is greater than 3, it means that becomes our domain. So our a is equal to 3. So that's the minimum value of what? Of a. All right. So that's what we are having here. So we could say the minimum value of a is 3. And then for b, for the value of a in part A, okay, find an expression for the inverse function of that. So what we are to do there is to get the inverse of that. So let's see. Now remember that the inverse function of a log function is actually an exponential function. Just from the beginning, you need to know that, so that when you get your answer, you need to remember that your answer should be in exponential form. So in this case, what are we having? We are saying f of x is equal to log of x minus 3. But instead of writing f of x, we have to have y is equal to log of x minus 3 base 2. All right, maybe the first thing that we need to do there is to interchange the variables. Remember the relationship that exists between a function and its inverse. The domain of the function becomes the range of the inverse function, and vice versa, of course. So that's why we actually have to interchange the variables. So here I'm going to have x is equal to log of y minus 3 base 2. Okay, so if we apply the definition here, that is, if we convert this statement here into exponential form, that becomes 2 to the power of x. Okay, so we're going to have 2 to the power of x is equal to y minus 3. All right, so we make y the subject of the formula. Okay, so we take this negative 3 to that side. We're going to have 2 to the power of x plus 3 is equal to y. All right, so the inverse or y, we are saying here it is equal to what? 2 to the power of x plus 3. Therefore, the expression for the inverse function of f, we have to use that notation, please. Okay, 2 to the power of x plus 3. That is actually our answer. So please take note that you should not end here. All right, we should always try and use the notation which actually shows that now that is now our inverse function. All right, so that's part 1. And then in part 2, what are we saying? We are to state the range of the inverse function. The range of the inverse function here. Okay, now remember what we said, the relationship that exists between the function f and its inverse. The domain of the function, it becomes the range of the inverse function. So we are simply just going to take this and have it there. But of course, since we are talking about the range, we should use y instead of x. So we are going to have what? Y should be greater than, our a is 3. So we are having here y is greater than 3. So that is the range of the inverse function. Y is greater than 3. All right. Now looking at question part C. All right. Let's see what we are saying here. The function g is defined by g of x is equal to 3x minus 2. All right. Evaluate g of f of negative 3. All right, so to evaluate this, we need to start with the inner function, of which the inner function here is the f, the inverse function of f. So remember our inverse function, it is 2 to the power of x plus 3. All right, so we need to get f of the inverse function of 3. So we need to substitute 3 there. So with that, if we have 3, we are going to have 2 to the power of 3 plus 3. So 2 to the power of 3, that's 8, plus 3, that will give us 11. All right. So then g of inverse of f of 3, that means we are talking here of what? G of 11, because this party here is equal to 11, so we are going to have g of 11. So g of 11, we are going to have 3 in brackets 11 minus 2. 3 times 11 is 33. 33 minus 2, that will give us what? 31. So that is our answer there. All right. So, and moving on then to part 2, show that f of g of 1 cannot be evaluated. All right, so we can just do what we need to do there. We start with the inner function, which is g of 1. All right, so what is g of 1? It means we are substituting g 1 into g. So we are going to have 3 times 1 minus 2, which gives us what? 1. All right. So what then is f of 1? We go back to our original function. F of 1, remember it's log of x there is now 1 minus 3 base 2. So we are talking here of log of negative 2 base 2. Now this is actually, and it cannot be evaluated because this is actually undefined. Okay, log of a negative is undefined, as we have already said there before. All right, so that's what we are actually having there for question 9. All right, question 10, it's on parametric functions. So we are having here the parametric equations of a curve are these ones here, where x is 4 cos 2 theta plus 3 sine theta, and y is equal to 5 cos theta, for theta is between 0 and pi over 2. Find the gradient of the curve at the point for which theta is equal to 1 radian. Okay, so what we simply need to do there is that we need to differentiate the function of x and the function of y. All right, and then of course we use the chain rule for us to be able to find dy dx, which is our derivative, okay, for us to be able to get the gradient. So let's differentiate the two functions. So the first parametric one is x is equal to 4 cos 2 theta plus 3 sine theta. So that becomes dx d theta. What is it going to be? It is going to be, remember this is a composite function, so there is a constant, we have it, it's 4 multiplied by the inner function is 2 theta. So if we differentiate that, we are going to get 2 multiplied by the outer derivative. The derivative of cos 2 theta is negative sine 2 theta. So we are going to have negative sine 2 theta plus the derivative of 3 sine theta is going to be 3 cos theta. So we need to simplify this before we do anything. What is it going to be? This is going to be negative 8 sine 2 theta plus 3 cos theta. All right, that's what we are having there. And then we do y. Okay, y 5 cos theta. We have y is equal to 5 cos theta dy d theta. It is going to be equal to 5 sine theta. All right, but remember of course that dy dx, the chain rule, dy dx is going to be dy d theta multiplied by d theta dx. That's what we are having here. So we just need to plug in. This is my dy d theta, and that's my dx d theta. So my dy d theta is 5 sine theta multiplied by d theta dx. Okay, so that's the reciprocal of this one here. So we're talking here of 1 over negative 8 sine 2 theta plus 3 cos theta. All right. Yeah, I noticed something here. We made a mistake here. This is supposed to be, remember the derivative of course is negative, so this should be negative here. We must have a negative here and there. So we have a negative there, negative there. Now simplified, this will give us 5 sine theta over 8 sine 2 theta minus 3 cos theta. What I did there was to remember negative over negative, it cancels out. So I first of all had to factor out negative from this from the denominator there. Okay, so that's actually what it comes to. And now that factored out negative 1 divided by negative 1, okay, that becomes positive. So this is the simplified expression. But now we need to get the gradient where theta is equal to 1 radian. So we can actually write it as that. The derivative of f where theta is 1. So if I substitute that, what am I going to get? I'm having 5 sine 1 over 8 sine 2, because 2 times 1 is 2, minus 3 cos 1. What am I going to get there? Okay, we'll get 0.7442 and so on. So simplified to 3 significant figures, that will be 0.744. That is what we are going to have. That will be the gradient of that function there. Okay, now moving on to the second part of the question, which is B. Find the value of sine theta at the point on the curve where the tangent is parallel to the y-axis. Now let me just, for you to have a visual and understanding of what is actually happening. Let's suppose that's the curve, and if this here is my tangent, because it's parallel to the y-axis, so suppose maybe that's my Cartesian plane there. If we have a tangent which is parallel to the y-axis, it means the gradient is actually undefined. That's what it means. So our derivative, this is our derivative here. When does it become undefined? This derivative dy dx can only become undefined if this denominator 8 sine 2 theta minus 3 cos theta is equal to 0. Okay, so if this is equal to 0, then that we are going to have an undefined gradient. So from there, they are saying find the value of sine theta. So I'll need to erase this for space. All right, so we are saying here 8 sine 2 theta minus 3 cos theta is equal to 0 to make the derivative to be what? To be undefined. So we are going to have 8 sine 2 theta minus 3 cos theta is equal to 0. That's when the gradient is undefined. So to solve this, I could, remember this is actually a double angle. Sine 2 theta is a double angle. If you check in your formula sheet, sine 2 theta is equal to 2 sine theta cos theta. So we have 8 sine theta cos theta, but of course that should multiply by 2, minus 3 cos theta is equal to 0. So if we simplify that, we are going to get 16 sine theta cos theta. Now if we take negative 3 cos theta to the other side, we are going to have positive 3 cos theta. So then we can cancel out cos theta. All right, if we cancel out that, what are we going to get? We are going to get 16 sine theta equal to 3. Then we divide both sides by 16. We get sine theta is equal to 3 over 16. So that is the value of sine theta, okay, for the tangent to be parallel to the y-axis at this particular point. Okay, so that's what we are having here. Quite an easy one.